Welcome back. This is continuing with triangle congruence and writing proofs in geometry. Last night, your homework was to get problems 1 through 8 on the worksheet. Tonight, your problems are going to begin with number 9. But before I talk about the specifics, I want to walk through this. So what we've been doing is taking a picture like this and reproducing it on paper so that we can annotate it. And then we note our givens, right? So given AD is congruent to BE. And then this one's weird. It says ADC is congruent to angle CDE is congruent to angle CED is congruent to angle BEC. It's a long string of them. And what we're trying to prove is that triangle ADC is congruent to triangle BEC. And we've been doing this a fair bit now. If I wanted to write a 2-column proof for this, I'd start by making my 2 columns. Statements goes on the top of the left. Reasons goes on the right. And what's the first thing I put? The given. Okay, so in this case, I'm going to put AD is congruent to BE, and my reason will be given. And the moment I add something to my t-table, what should I do to the graph or the picture? Mark the information on my picture so that I'm going to be able to determine, is it AAS or ASA or SAS, etc. So I've put one given in here. Now I want to figure out which of these pieces of information are important to me. So let's take a look at angle ADC, angle ADC, angle CDE, angle CED, and angle BEC. Boy, that's a lot of different angles. I'm going to take a moment and I'm going to just look at my proof, what it is I'm aiming for. It's asking me to take this triangle, ADC, and make it congruent to this triangle, BEC. So given that piece of information, let's go back and look. Is angle ADC helpful to us? ADC, is that in one of the triangles? Yeah, so that seems good to us. What about CDE? That's outside. I'm not going to use that piece of information. What about CED? Also outside. We don't need that. But do we need BEC? We do. So that's the piece of information out of this that I'm going to extract and use in my proof. I want to say that angle ADC is congruent to angle BEC. That's also given. And I've marked that already. Now, my goal here is to express my final solution, right? That my 2 triangles, ADC and BEC, are proven to be congruent. When I do this, what will the answer here, the reason, look like? Good. SAS, AAS, SSS, one of those 3-letter combinations. So that means I have to have how many facts in evidence to be able to justify the triangles are congruent? 3. Do I have 3 now? No. So I'm missing one. So somewhere in there is another piece of information that I get to use and that I wasn't given as a given. What is it? Vertical angles. Okay. So I'm going to skip a little step here and I'm going to say angle. Do we agree that this would be a good example of the vertical angles? And this one, so angle ACD is congruent to angle BCE. What's my reasoning for that? Well, the definition of vertical angles says they are vertical angles. I'm taking it one step further to say if they're vertical angles, then they're congruent. But you're right. I had to previously state that angle ACD and angle BCE are vertical angles. And that's the definition of vertical angles. And that gives me my 3 facts, doesn't it? When I mark that in the picture, I can now see, using our Mario Kart analogy, what is this? SSS, ASA, AAS, angle, angle, side, right? Why can I not call this ASA? There's 2 non-supported things. This angle and this side are both non-supported in a row. So game over. Okay. So in this case, I'm going to say that these triangles are congruent by AAS. And is that all I'm trying to get to? Is that the end of the game? It is. My prove matches what I've said. So I can wrap this up by saying QED, I'm finished. Quod erat demonstratum. So this is what you should have done in last night's homework. Any questions on that? Okay. Today, we're going to take it one step further. This is problem number 9, right? So I've done one of your homework problems for you, except I haven't. Because I'm going to ask you tonight to do problems 9 through 24. And all the odd numbers, I want you to do in a new format that I'm going to teach you right now called flow proof format. And all the even numbers, you're going to do just like you've done in 2-column proof. So let's take a look at what a flow proof might look like. And for this, I'm just going to use the picture we've already drawn because we just went through that whole process. You can do the same. So for a flow proof, it's the exact same information, but it's written in a more graphically presented format that gives you more information about what leads to what. So I'm going to start with the same information, a given. I'm going to say AD is congruent to BE. And I'm going to put a little box around it. And instead of having a T-table with lines matched up, this box gets a little title below it that says the reason is that it was given. And then I'll take my second piece of information, angle ADC is congruent to angle BEC. Put a little box around it, and I write given under it. So not so different so far, right? Just a little geography. What's that third fact that we got? First, we got to say that the that the angles are vertical, right? So we said angle ACD and angle BCE are vertical angles. Put a box around that. Say definition of vertical angles. Now, here's where we begin to get some value out of this system. Each of these things came out of nowhere. In other words, the given didn't need to have prerequisite information. It's starting stuff. And we know that the definition is always true. It comes out of thin air, so to speak. But our next statement, where we say that angle ACD is congruent to angle BCE, my reasoning for that is if vertical angles, that's my hypothesis, then congruent. So my conclusion matches what I'm saying now, and my hypothesis has to be previously stated. If I didn't know they were vertical angles, I can't claim that if they are vertical angles, they're congruent. And this arrow ties together the information that feeds this box. And we know that our end-up goal here is that we're going to try to get triangle ADC congruent to triangle BEC. And how many pieces of the puzzle does it take to make this claim? 3. Do we have 3? Here's one. Here's 2. And here is 3. In other words, I expect to see 3 different congruence statements feeding into this so that I can claim by angle, side, this is congruent. And to wrap that up, I can say I'm finished, QED. It's the same information, isn't it? It's just presented in a slightly different visual way. And there's no rules about whether you start on the left and flow to the right, or start on top and flow down, or start right and flow left. It's totally up to you that way. Any questions? Okay, let's flip the page over and let's do problem 11. And we're going to do it in a flow-proof format. So how do I start? How do I start? The given, okay? So I'm going to choose one given. Angle E is congruent to angle U. We should label this, say it's number 11, so you're keeping track of what you're doing. And underneath this, I'm going to write given. Now what? I should annotate my picture with that, shouldn't I? Angle E and angle U. Now I'll take a second given. And actually, I'm going to do this one a little different. I'm going to do it top down, just to show that it doesn't matter. Also given. Yep. So we're doing 9 and 11 as flow proofs. And you'll do 10 and 12 as 2-column proofs. And now I need to come back here and mark RS and PS as congruent. And I know that I'm going to end up down here RE congruent to PU. First of all, you notice the mistake here? It's a notation issue. What's wrong? Excellent. They should either be equal, or there should be a segment over the top saying that these are segments that are congruent. So please make that adjustment. Now, what kind of reason will there be here? No, the word prove will never, ever, 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 ever be a reason. Okay, I like that you're thinking about those, and those are great for proving triangles are congruent. Those things are theorems to prove triangles are congruent. Are these triangles? They're segments. So we're expecting that one step before this, we're going to end up with something that says, for example, triangle RSE is congruent to what triangle? I don't think that matches. Look at what we've done. RSE. So it goes the unmarked angle along the marked side, ending up at the marked angle. So where should we start this one? PSU. Remember we talked about triangle congruent statements and how important they are? So this is what you talked about. This one's going to have AAS or SAS or SSS to prove that. And then from that piece of information, we're going to say, well, if the triangles are congruent, then I know every single corresponding parts of that triangle. Remember R and E and P and U? What was the 5-letter acronym we used for this? See if you can remember it. Nice. Nice. CPCTC. Corresponding parts of congruent triangles are congruent. And what that says is once the triangles are congruent, you can claim that any matching parts are congruent. So that takes care of our last step, but we still have to justify these triangles are congruent. How many pieces do we need to prove triangles are congruent? 3. Do we have 3? No, we don't. So we need a third piece of information that's in this puzzle already that we just can't see yet. They didn't give it to us on a silver platter. What is it? Vertical angles again. How do I name this angle over here? Good. USP would be great. Why can I not name it S? Good. It's ambiguous which angle would be S. It's true that this point is S, but I can't call this angle S because this angle and this angle are different sizes, different locations. They're not interchangeable. So I need to call it USP. Angle USP and angle ESR are vertical angles. What's my reason for claiming they're vertical angles? Good. Definition of vertical angles. And now that I've claimed they're vertical angles, I can directly draw from that a fact. What's true then? Beautiful. I can now say these two angles are congruent. Why? Because if they're vertical, then they're congruent. I said they're previously vertical. Now I'm saying they're congruent. So this fits perfectly. And this is one fact leading to this. Let's mark it in our picture so that we can figure out what the orientation is, what the three-letter theorem is. Got all three of our facts. Do we have the right facts? Are these three giving me a picture that lets me use Mario Kart to come up with a theorem that proves triangles congruent? Good. What do we call it? What's the three-letter acronym that tells us these are congruent? SAA, is that the way we say it? AAS, good. And now do we have a comprehensive three ideas coming together to feed this triangle congruence? The triangle congruence says that these parts are congruent by CPCTC. So QED. How are you feeling about flow proofs? 5. I actually think I like them better than two-column proofs. It makes more sense visually in my brain. 3. It's interchangeable. I could do either one. 1. These are awful. They don't make sense to me at all. They're not linear. Doesn't make sense.
What is CPCTC?
CPCTC stands for corresponding parts of congruent triangles. May remember that we did a homework a couple of days ago where you had CPCTC and you wrote out all the parts. Yeah. Okay, so today you're doing 9 through 24. That's your homework. All the odd numbers you do like this in flow proof. All the even numbers you do in two-column proof. Eventually, you'll get to pick which form you like to use on your proofs. For today, I'm holding you accountable to using both formats to show me you know how to use them.
CPCTC is when everything's the same.
CPCTC can only be used after triangles are proven to be congruent, like this. Then you get to say if the triangles are congruent, then any pair of matching corresponding parts are also congruent. Okay, you guys have the work period.
Use the same.
Just a second.